Yeah, hi. మనం స్టార్ట్ చేద్దాం. ఓకే, ఈరోజు మనం చెప్పుకోబోయే టాపిక్ ఏదంటే నాట్ ట్రాన్స్ఫర్సల్. ఓకే, వాట్ ఈస్ ద యూజ్ ఆఫ్ దిస్? వీ కెన్ కాల్ ఇట్ యాజ్ ఆల్సో ఏ నాట్. మనం ఈ నాట్ అనేది ఎందుకు యూజ్ చేస్తాం, ఎప్పుడు యూజ్ చేస్తామని. ఓకే, ఐ థింక్ యూ కెన్ సీ మై స్క్రీన్, రైట్? This is a NAT traversal, which we can call it as a NAT as well. When we use NAT transversal, okay, what is the significance of this NAT transversal in IPsec? Okay, see, yesterday మనం ఏం చెప్పుకున్నాం, మనం డైరెక్ట్లీ కనెక్టెడ్ చెప్పుకున్నాం కదా. మనం వన్ సైడ్లో ఉన్న ఫైర్ వాల్, అదర్ సైడ్లో ఉన్న ఫైర్ వాల్ డైరెక్ట్లీ కనెక్టెడ్, ఆర్ otherwise it is not directly connected కాకపోయినా when there are multiple devices it will be connected through the multiple devices, but there are no NAT device, okay, in between. If for suppose if there is a NAT device in between both the sites, site 1 and site 2, okay. Chakra, can you mute? Yeah. See, if there are if there is any NAT device in between IPsec feeds, see here we have site 1 VPN device and site 2 VPN device. Here there is a NAT device in between. Basically IPsec uses protocol, ESP protocol, right? ESP or AH protocol, which we have an protocol number, okay. And whenever traffic is flowing from one side to another side, ఎప్పుడైతే మనకి ట్రాఫిక్ వన్ సైడ్ నుంచి అదర్ సైడ్ ఫ్లో అవుతున్నప్పుడు నాట్ డివైస్ మధ్యలో ఉందనుకో, ఈ నాట్ డివైస్ అనేది ఏం చేస్తుంది అంటే పోర్ట్ ట్రాన్స్లేషన్ ఉంటుంది అనమాట. ఇఫ్ ఇట్ ఈస్ డూయింగ్ ఏ పోర్ట్ ఫార్వర్డింగ్, అండ్ యూ కెన్ కాల్ ఇట్ యాజ్ అన్ L4 device as well, okay. If it is doing port forwarding, when this L3 traffic coming on hitting this NAT device, it won't allow the this L3 traffic, because it only do the port forwarding, not than L3 protocol, okay. So in that situation we can use a NAT traversal, okay, which we can call as nat as well. We can use a nat on both, we can enable nat on both the ends, so that whenever the traffic is whenever nat transversal is enabled, what this site 1 device and site 2 VPN device will do is it will convert the, we are using a UDP port 500 right here, so it will convert the UDP port 500 to 4500, and it will send through the NAT device, and NAT device will be able to translate that and able to pass the traffic to the other side, okay. And if you see here how the site 1 and site, sorry. Yes, yes. యాక్చువల్గా అయితే ఇక్కడ ఏం జరుగుతుందంటే this is an UDP is layer 4, right? So UDP uses only the port 500, and ESP is a protocol which we are using in the IPsec. So the ESP is a protocol which we don't have a ports, okay, to send the traffic, okay, to send the actual data traffic we can use an ESP, but ESP is a protocol which don't have an ports, okay. And on the other side we have the this is a NAT device which cannot be cannot be transmit that ESP packet. Okay, this L4 device cannot encrypt or decrypt those ESP packets. Okay, and so to do that, we are enabling the NAT transversal. So what NAT transversal will do is it will use an UDP port 4500 here, and it will send to the NAT device, and whatever the encrypted packets will be coming on the NAT device, it will try to encrypt and decrypt and will send to the site 2. Okay, from site 1 to site 2. Without NAT transversal, we can't able to send the actual data from site 1 to site 2 when there is a NAT device in between. అర్థమైందా? హ్యాకర్స్కి హ్యాకర్స్కి అని ఏం కాదు, మన కమ్యూనికేషన్ కోసం మాత్రమే అది. ఎందుకంటే వీ హ్యావ్ టు ట్రాన్స్ఫర్ అవర్ డేటా ఫ్రమ్ వన్ సైడ్ టు అందర్ సైడ్, రైట్, త్రూ ద IPsec tunnel. So if there is no NAT device, it will be easy to transmit. Okay, because the NAT device will use an port numbers, but for our IPsec, we are using the ESP protocol to send an actual user data. Okay, for that ESP, we don't have then what we call, we don't have that port numbers. Okay, what it will do is when we enable NAT transversal, this actual ESP data will be encrypted using the other UDP 4500. Okay, whenever the data reaches this NAT device, it will check that ports and it will decrypt that L4 packet and will send that extra will convert that port 500 UDP port 500 to 4500, and will transfer that data to the site 2. It will not helpful for it is not for the hackers, or it will not ఇది మనం మన యూజర్ డేటా ట్రాన్స్మిషన్ కోసం మనం యూజ్ చేస్తాం వెన్ దెర్ ఈజ్ అ నాట్ డివైస్ ఇన్ బిట్వీన్, నాట్ ట్రాన్స్ఫర్సల్ అనేది. ఇఫ్ దెర్ ఈజ్ నో నాట్ డివైస్, we are no need of using the NAT transversal. It depends. If there is no NAT device, we are no need of using NAT transversal. Yeah. ఏది అర్థం కాలేదు. అవును. మ్మ్. అంటే ఐ మీన్ నాట్ డివైస్ ఉండొచ్చు, కానీ ఈ మన ఐపీసెక్ పాత్లో మాత్రం నాట్ డివైస్ ఉండొచ్చు, ఉండకపోవచ్చు. మనం ఇంటర్నెట్ రీచ్ అవ్వాలంటే ఖచ్చితంగా నాట్ కావాల్సిందే. బట్ వెన్ ఎవర్ వీఆర్ క్రియేటింగ్ ఎన్ ఐపీసెక్ టనల్, if there is any NAT device in between that IPsec tunnel, this concept will NAT transversal will be enabled. మేబీ ఇంటర్నెట్ అండ్ ఇప్పుడు మనకి ఇక్కడ ఈ డయాగ్రామ్లో చూసుకుంటే మనకి సైట్ 1 సైట్ 2 డివైజెస్ ఉన్నాయి. ఈ సైట్ 1 సైట్ 2 రెండు ఫైర్ వాల్స్ అనుకుంటే ఇట్ ఈస్ కనెక్టెడ్ వయా ఇంటర్నెట్ ఓన్లీ, బట్ ఇన్ బిట్వీన్ దర్ ఈజ్ ఎ నాట్ డివైస్. ఓకే, మనకి ఈ విపిఎన్ డివైజెస్కి ఇంటర్నెట్ ఇంకొక దగ్గర నుంచి అయినా రావచ్చు, కానీ ఈ ఐపీసెక్ టనల్ నుంచి అయినా రావచ్చు, వేరే ఇంటర్ఫేస్ నుంచి అయినా రావచ్చు. ఓకే, బేసికల్గా అయితే ఈ ఐపీసెక్ టనల్ మనకి ఎప్పుడైతే ఐపీసెక్ టనల్ క్రియేట్ చేస్తుంటామో, ఇఫ్ దెర్ ఈస్ అ నాట్ డివైస్ ఇన్ బిట్వీన్ ద ఐపీసెక్ టనల్, వీ కెన్ యూజ్ అ నాట్ ట్రాన్స్వర్సల్. ఓకే, జరగాల్సిందే. ఎందుకంటే ఈ దెర్ విల్ బి అదే మనకి నాట్కి ఐపీసెక్కి ఇన్కంపాటబిలిటీ వస్తుంది. ఎందుకంటే మనకి నాట్ అనేది మనకి L4 కదా. ఇట్ విల్ ఓన్లీ ఇట్ విల్ డూ వెన్ దెర్ ఆర్ యూజింగ్ ప్యాట్ ఇన్ పోర్ట్ అడ్రస్ ట్రాన్స్లేషన్, it will use an ports, but our IPsec don't have an ports when it is transferring the user data. Okay, మనం ఎప్పుడైతే యూజర్ డేటా ట్రాన్స్ఫర్ చేయాలనుకుంటామో అప్పుడు మనకి ఏమవుతుందంటే ఇక్కడ ఈఎస్పి అనేది మనకి ప్రోటోకాల్, వీ డోంట్ హ్యావ్ అండ్ పోర్ట్ నెంబర్స్. సో మన ఇక్కడ నాట్ ట్రాన్స్ఫర్ ఏం చేస్తుందంటే ఈ ఈఎస్పి ప్రోటోకాల్ డేటాని ఈ L4తో ఎన్క్రిప్ట్ చేసి పంపిస్తుంది అనమాట. L4తో ఎన్క్రిప్ట్ చేసి పంపించినప్పుడు బయటికి వెళ్ళేటప్పుడు ఇది ఏం చేస్తుందంటే యూడిపి 500ని యూడిపి 4500తో ఎన్క్రిప్ట్ చేసి పంపిస్తుంది. సో ఇప్పుడు నాట్ డివైస్ రిసీవ్ చేసుకొని పోర్ట్ అడ్రస్ ట్రాన్స్లేషన్ చేసుకొని డిక్రిప్ట్ చేసేస్తుంది. డిక్రిప్ట్ చేసి L4 ప్యాకెట్ని మీద ఈఎస్పి డేటాని మనకి ఇంటర్నెట్లోకి పంపించేసి సైట్కి రీచ్ అయ్యేలాగా చూస్తుంది అనమాట. This is mainly the NAT transversal we can use mainly when there is a NAT device in between the site 1 and site 2, when we are forming IPsec tunnel, and if there is any NAT device, then only NAT transfer will be used. Otherwise no need of NAT device. Okay, sorry, NAT transversal. మనకు అదే విధంగా ఇక్కడ మనకి టోపాలజీ ఎట్లుంటుందో తెలియదు, అంటే ఇంటర్నెట్లో ఏముంటాయి మనకు తెలియదు. బట్ హౌ దిస్ సైట్ 1 అండ్ సైట్ 2 డివైజెస్ విల్ నో దెర్ ఈజ్ ఎ నాట్ డివైస్ ఇన్ బిట్వీన్ ద సైట్ 1 అండ్ సైట్ 2. ఓకే, how the site 1 site 2 will do is, first there are two steps. There are it will the site 1 and site 2 follow the two steps. Okay, let me there are the two steps where how it is like, first it will detect if both site A or site 1 and site 2 devices support NATs. Okay, how ఇది ఏం చేస్తుందంటే ఫస్ట్ నాట్ సపోర్ట్ చేస్తా లేదో చూస్తుంది ఫస్ట్. అది ఎలా అంటే మనకు నిన్న మెయిన్ మోడ్లో మనకి ఐపీసెక్ మెసేజెస్ చదువుకున్నాం కదా. మెయిన్ మోడ్లో మెసేజ్ 1, మెసేజ్ 2 అండ్ మెసేజ్ 3, మెసేజ్ 4, మెసేజ్ 5, మెసేజ్ 6. ఇక్కడ ఏం చేస్తుందంటే ఈ రెండు మనకి ఫస్ట్ నాట్ సపోర్ట్ చేస్తే లేదో తెలుసుకోవాలి ఫస్ట్. దెన్ ఓన్లీ నాట్ డివైస్ ఉందో లేదో డిస్కవర్ చేస్తుంది. ఫస్ట్ ఈ రెండు నాట్ సపోర్ట్ చేస్తాయో లేదో తెలుసుకోవాలంటే ఇక్కడ ఏం చేస్తుందంటే ఫస్ట్ ఇది సైట్ 1 అనేది ఫస్ట్ మెసేజ్ సెండ్ చేస్తుంది అనుకో, అక్కడ ఒకటి nat-t పేలోడ్ అనమాట. ఇక్కడ చూస్తే ఇక్కడ చూసారు కదా, ఇక్కడ nat-t పేలోడ్ ఇంక్లూడ్ చేసి పంపిస్తుంది. ఓకే, in the first message you can see here, yeah, here ikkada chusukunnatlayite in the first step, in the main mode of the phase 1, it will send an NAT payload. In the payload security access, it will also add a nat-t transversal. Okay, negotiation of nat-t transversal in IKE. Whenever we enable nat-t and they are forming an IPsec tunnel in the message 1. Okay, ఫస్ట్ మెసేజ్లోనే సైట్ 1 అనేది పంపిస్తుంది. ఒకవేళ సైట్ 1 ఇనిషియేటర్ అనుకుంటే ఫస్ట్ మెసేజ్ ఇనిషియేట్ చేస్తుంది కదా. ఈ ఫస్ట్ మెసేజ్లో మనకి సెక్యూరిటీ అసోసియేషన్ మనది హ్యాగల్ పారామీటర్స్ అన్నాం కదా, ఆ హ్యాగల్ పారామీటర్స్తో పాటు ఈ nat-t ట్రాన్స్వర్సల్ అనేది పంపిస్తుంది అనమాట. ఎందుకు? ఐ కెన్ సపోర్ట్ అండ్ nat-t అని చెప్పడానికి. ఓకే, ఇన్ ద సేమ్ వే ఇన్ ద స్టెప్స్ టు దిస్ site 2 also, it will send an nat-t payload. Okay, nat transversal payload in the second message. Okay, how the both the device know NAT is supported in the sense it will comes to know in the first two messages, okay, because in the first two messages the site 1 router and site 2 router or firewalls will send an nat-t payload along with the parameters that they are negotiating, okay. It will also negotiate the nat-t, okay, in the first two messages. After that, after first two messages, both the devices will know that both the devices will support nat-t. Then it has to perform the it has to know the whether NAT device is there or not, okay. ఈ రెండింటి మధ్యలో NAT device ఉందో లేదో తెలుసుకుంటే ఎప్పుడు once these both the devices are support nat-t, then the next step is these both the devices need to know అవి ఏం చేయాలంటే ఈ NAT device ఉందో లేదో తెలుసుకోవాలన్నమాట. ఎలా తెలుసుకుంటాయంటే in the third and fourth message what it will do is we have an source IP and source port, right? We in the first and two messages they will come to know the source IP and source port along with the destination IP and destination port, okay. ఇది ఏం చేస్తుంది అంటే ఇన్ ద థర్డ్ అండ్ ఫోర్త్ మెసేజెస్ వాట్ ఇట్ విల్ డూ ఇస్ ఇట్ విల్ what the site one will do is it will has the source IP and source port and destination IP and destination port, okay. ఇప్పుడు మనకి ఇది సోర్స్ ఐపీ అనుకుంటే సోర్స్ పోర్ట్ ఈ రెండింటిని కలిపి ఒక హ్యాష్ వాల్యూ క్యాలిక్యులేట్ చేసుకుంటుంది అనమాట, ఓకే. ఇది ఎవరు సైట్ 1, ఓకే, సైట్ 1 రౌటర్ ఆర్ ఫైర్ వాల్. అదేవిధంగా డెస్టినేషన్ ఐపీ ఇది డెస్టినేషన్ ఐపీ డెస్టినేషన్ పోర్ట్, ఓకే, ఫ్రమ్ L3 and L4 packets they have the source IP source port, destination IP destination port, okay. They will calculate the some hash values, okay, and this is in the third message where the site 1 will send and site 2, and in the fourth message see here this is from site 1 to site 2. This is the third message where it can add an hash value of the source and hash value of the destination, okay. This is a NAT, we can call it as a nat-d payload. Nat-d means NAT discover payload, okay. In the first two messages nat-t payload which is NAT transversal. After two messages it will they want to know whether NAT device is exist in between the site 1 and site 2. For that they will send an nat-d payload in third and fourth messages. Third message is from site 1 to site 2 where it will hash source IP and source port and destination IP and destination port, okay. If you see here this is from site 1 source port and source IP hashing and destination port and destination IP hashing on the site 1 router, okay. This is on the third message, and after that the same thing it will do what the site 1 does, and site 2 also do the same thing. It will also from the second message it can come to know that source IP and destination source port and destination IP and destination port, right? It will also do the hashing, okay. Once these both will be exchanged we can see that it will both will compare the what it will compare this both the hash values it will compare, okay. If you see here both the hash values it will compare, okay. If we see here we have an source IP and source port hashing as an AB1, okay. We can see here AB1 and the destination IP destination ports are 8B4, okay. And if you see on the fourth message it will have an 8B4 and destination IP will be 667. So these two hashing values will be compared by both the sites, okay. And it will if the both the hashing values are same the routers came to know that there is no NAT device in between, because whenever the NAT device is exist in between these hashing values will be changed, okay. If you see here This is a 8B4, and we have an 8B4 here. Okay, and if you see here, we have an AB1, but here we don't have AB1. So by this we can come to know that if the hashing values are not matching, okay, if the hashing values are not matching, it will confirm that there is a NAT device in between site 1 and site 2. What the NAT device will do is, whenever they are sending the hashing values, this device will interfere and change the hash values. It will do its own hashing, and it send to the both the device. Okay, whenever third message is going from site 1 to site 2, it will change the hash values and it send to site 2. And whenever, so in the fourth message site 2 is sending from site 1, it will this interfere, this NAT device interfere, and it will send the its own hashing value. So the both the device will compare the both source hashing and the destination IP hashing, and it will come to know that if the hashing values are different, it will come to know that NAT device is in between site 1 and site 2. Okay, this is how these both routers will come to know there is a NAT device in between uh, site 1 and site 2. Okay, this is how the both the firewalls will discover NAT device, which is an nat-t payload. And after that, after third and fourth message, what it will do is the NAT, it will come to know that NAT device exists along the IPsec path, and it will be in the IPsec phase 1. It will change the site 1 of the router of the site 1 or firewall of the site 1. It will change its port 500 to port 450, and it will send in the fifth and sixth messages. If you see here, we are seeing that it has changed from 500 to 4500. Okay, this is the uh, make a note of that. After when there is an NAT device, in the fifth and sixth messages, the source port or destination port will be changed. The UDP port will be changed from 500 to 4500, and it will exchange between site 1 and site 2 in fifth and sixth messages. Okay, what it will do is this after converting this UDP 500 to 4500, this encapsulation packet, okay, ESP packet will be encapsulated in the uh, this UDP protocol. Okay, in the this UDP will encapsulate the ESP packet and will send across the site 1 along with the uh, it will transfer along with the NAT device. This NAT device will do a port translation and will decapsulate that UDP packet, and it will send the entire ESP packet to the site 2. Okay, and anything else? Yeah, actually, we don't have lab for this. I just giving a brief idea. If we want lab, we need an NAT device in between the our site 1 and site 2, like our firewall 1 and firewall 2. Hmm? GNS3 రౌటర్లో చేయలేం మనం. ఇది యాక్చువల్గా మనం నాట్ కాన్ఫిగర్ చేయాలి మొత్తం. This is I'm just giving a brief about how how the traffic or the user data is flow from site 1 and site 2 when there is an NAT device in between. If you want to do a lab, we need to have an NAT device, and we need to configure a NAT. In between that, we need to create a routes to pass traffic from this side to that side. But in the real-time scenarios, these will be already taken care by the network administrators, okay? Because the network administrator will have idea about all the topology information, and they will be responsible for configuring uh, all these NAT devices and routing part. This is just I'm giving an brief idea about NAT transversal, how the NAT transversal is used. In the Palo Alto, we have option called NAT transversal, and not only the Palo Alto, every firewall and every router which are supported IPsec will have this, and will be enable this NAT transversal when there is an NAT device in between uh, the site 1 and site 2, or firewall 1 and firewall 2. If you see this on the last packet capture, this after configuring, after knowing that NAT device, this UDP packet will be used by the NAT device, and it will do an port translation. After that, it will decapsulate this UDP packet and only send that ESP packet to the, based upon this destination IP, it will transfer that packet to the site 2. And we have some troubleshooting scenarios in the IPsec. I have included here in this. If phase 1 is down, how what needs to be checked on the firewalls, and how we can approach when there is phase 1 is down between site 1 and site 2. Okay, what is the first step we need to do is we need to check the reachability between the both the sites. Okay, yesterday we have also encountered same issue, right, where there is no reachability between the site 1 and site 2, because we we have configured an static IPs where those firewalls are not directly connected. Those are all connected to the cloud, and we have configured a NAT. Okay, and we got an IP address by configuring a DSCP client. So first we need to check the reachability. So we need to ping that from one peer to the other peer. And if we are not able to ping, we need to check what's happening on that. Okay, and if we are not pinging, we need to go on to the monitor tab of the firewall, and we need to check if there are any security policies or blocking this ping. Actually, we need to enable ping on the interfaces, okay, by configuring the in management profile. We need to allow the ping. If we are not allowing the ping, we don't know that whether that peer will be reachable or not. So we need to check that as well. Okay, if the management interface profile is also configured, we need to check the security policies, whether any of the security policies are blocking these ping packets. Okay, and after that we need to, whenever you are seeing issues with the IPsec, two things we need to make sure that: check that system logs and ikmgr log. Okay, we have a command called less mplog ikmgr.log, and in the monitor tab we have an system logs. These two things are the main things when you are troubleshooting the IPsec issues. Okay, in the IPsec phase 1, we need to check IK identity. Identity means we have to check the every parameters. Like yesterday we have missed in the phase 2. Some parameters are not configured properly, and the parameters are not matching. So IPsec phase 2 tunnel didn't come up. So for that purpose, we need to check each parameters, whether each parameters is matching on both the sides or not. Okay, and if that is also matching, and we need to check, we for suppose for sure we need to allow IKE protocol and IPsec protocols. Okay, yesterday I have configured policies, and I have allowed all the I have made it as an application source. Any means it will allow all the applications. So if you want to use that policy for specific IP, IKE and IPsec, we need to allow both, on only both. If not, we can use any as well. Okay, and we need to check proposals are correct, and if there is any mismatch in the parameters, we can comes to know using this command. Okay, ikmgr.log. Okay, and in the phase one we can also configure pre-shared key, right, for authentication. This pre-shared key is also must and should match on this both the sides should be match. Okay, if you are not able to isolate issues based upon all these above points, we need to take the packet captures. Okay, we need to take the packet captures uh, between the two sites. Okay, between the two sites, and we need to check whether all the modes and all the messages is all the messages are transferring from one end to other end. Okay, and we need to also check whether any nat-t is enabled. Okay, and we need to have also in the packet captures we can comes to know whether nat-t is enabled or not, and we need to check the ports as well. And how we can approach and how we can troubleshoot the when IPsec tunnel phase 1 is down. Okay, do you have any doubts on this phase 1? Yeah, yeah, yeah. Hmm. Yeah, yeah, actually the passwords are keep on changing. Okay, they are changing the passwords because this is for every batch it is going to change the passwords. For the website we have one login. For the website we don't need to have the logins, but for accessing these all these videos and PPTs, we need an password to access. uh, they are changing the passwords in between. Frequently they are changing because once the batch is completed, they are changing the password and they are using creating a new one. Yeah, this is all about the phase one, and if we go for the phase two, we need to. This is also we need to check the IKMGR log only. For this IKMGR log, we need to check whether all the proposal in this parameters are matching or not. Okay. After that, we need to check the bidirectional traffic. Bidirectional traffic means once we can check show VP. This is a command which we have executed yesterday as well. Show VPN, IPsec tunnel and tunnel name. We can see whether the tunnel name and tunnel parameters are matching on both the sides or not. And also we need to, this is one thing which we haven't discussed. PFS in the phase 2 we have an PFS means perfect forward secrecy, which is used instead of DH. we can use this perfect forward secrecy. If you are configuring PFS on one side and if you are using DH group on other side, there will be no use of the IPsec phase 2 will won't come up. We need to use, if we are using DH key, we are to use a DH group in the both sides. If you are using PFS, we need to use PFS on the both sides. Okay, and you can also know with this command whether we are using PFS or DH group. Okay, and in the phase 2, this proxy ID is also the main thing. The proxy ID is where when we configure proxy IDs means one side we are using Palo Alto and other side we are using other vendor, then only the proxy IDs will need to be configured. If you are using both Palo Altos, no need to configure any proxy IDs. All the traffic will be routed using the virtual routes. Okay, and yesterday we also discuss about encapsulation and decapsulation, right? This is also main thing in the phase 2. Okay, we need to check whether encapsulation and decapsulation is happening on the firewalls. Okay, if encapsulation is happening, the firewall is sending the traffic. Okay, and if decapsulation is, see, if encapsulation bytes are increasing and decapsulation bytes are not increasing, we can comes to know that encapsulation means packet is encapsulating and sending outside. Okay, decapsulation means packet is coming from the other end and we are decapsulating, means decrypting. Okay, if encapsulation bytes are increasing and decapsulation bytes are not increasing, we are sending the traffic but we are not receiving any traffic from the other end. Okay, in the same way, if decapsulation packets or bytes increasing and encapsulation bytes are not increasing, we can make sure that we are not sending the traffic but we are receiving the traffic. This is how we can verify this phase 2, and we can check with the command show VPN flow name, and we can use a tunnel ID or tunnel name. Okay, if you use tunnel name or tunnel ID, we can get all the information of the tunnel name. And if you use for particular if you want to match with the bytes, we can get only the encapsulation and decapsulation bytes. And we need to check whether they are both increasing. For sure, they have to increase. If any one of the one is not increasing, there will be an issue. Okay, and this is also the same thing. If encapsulation bytes are constant, we have discussed about this. And also you need to know whether policies are dropping the traffic or not. We need to check the policies as well. Okay, in the monitor traffic logs, we need to check the policies whether this IPsec packet is dropping or not, if when phase 2 is not coming up. Okay, and this is how phase 1 and phase 2 we can troubleshoot when phase 1 is down and phase 2 is down. And another scenario, both the phases are up but traffic is not flowing through the tunnel. Okay, if traffic is not passing through the tunnel, we need to check the security rules and security policies as well as routing. Okay, tunnels are up means all the parameters are matching and the IKE and IPsec are allowed on the firewalls, and both the phase 1 and phase 2 are up. But here in this case, the traffic is not flowing. Traffic is not flowing means we have to check the security policy. Security policies, why? For the whatever the traffic, if see yesterday we have an scenario like the source user 1.1.1 is reaching to 2.2.2. If you are created a policy to deny the traffic to 2.2.2.2. Okay, and it is matching with one of the security policies and it is dropping the traffic for 2.2.2. So in that case, we need to check the policies, why it is, why, who configured that and why it is configured. If it is configured unintentionally, we need to allow the traffic to pass to the 2.2.2, as well as we need to check the routing as well. If the security policies are okay, check the routing whether we have route to the 2.2.2.2. Otherwise, the packet or the traffic won't pass through the tunnel for this 2.2.2 destination. And this is the second point is about the nat-t only. Okay, port address translation means pat. whether there is any NAT device in between the site 1 and site 2, and we need to make sure that NAT is enabled. And if we haven't enabled nat-t, it will the in between the nat-d silently drops the packet, and the traffic won't pass through from site 1 to site 2, or site 2 to site 1. Okay, we need to check that thing as well. Okay, this is how we can this is how we can check when phase 1 and phase 2 is up but traffic is not flowing. These are some checks that we need to perform. Okay, these are the some basic or the major things that we need to check, but depends upon the topology and uh, customer environment. There are multiple things that will be once we have familiar with doing the lab or doing multiple things, we can comes to know. Okay, but these are the major things that we need to check. Okay, this is all about NAT transversal of IPsec and some troubleshooting scenarios. Okay, any doubts on this? Yeah, you can do the lab once. Once you are doing the lab, you can come to know how it works and what needs to be done. Okay, once you are start doing the lab, we can comes to know. Okay, this is all about the IPsec. By this, we can complete the IPsec. Okay. Oh yeah, Cloud Lab work అవుతుంది. I will stop the recording here. Do you have any doubts? If don't have any doubts, I can stop recording and